Here, the discovery of radioactivity. As I mentioned earlier, you can read this one yourself. This is about history. Okay, I just want to pay attention to the subtopic radioactivity. Okay, I have mentioned just now that radioactive is random and spontaneous decay process. What do we mean by random and spontaneous? This means that this process does not depend on pressure and temperature. Uh, Random and spontaneous decay process of unstable nucleus. Okay, the reason why this happens is because radioactive substance is not stable. Okay, that's what you need to remember. Otherwise, it wouldn't happen. Okay, unstable. The reason why the decay process happens is because it is unstable. What is unstable here? Nucleus. Okay, nucleus. So we have learned that we have nucleus in the middle, and then we have electron orbiting it. Right. This is what we learned before. So what we are discussing here, we are discussing the nucleus. That is why the topic here is about nuclear. Nuclear refers to nucleus activity. Okay. And then, as I mentioned earlier, we have three types of radiation. The first one is alpha, next one is beta, and last one is gamma. But gamma is not particle. Gamma is ray. That's why we use the term ray for gamma. Okay, now, this is one example. Okay, look carefully this one. Uranium. Okay, uranium. You can see here uranium. The number here is 238. 238. Okay, where does the number come from? 238 here comes from the addition of the two numbers here. 92 plus 146. We have 92p. P stands for proton, and 146 N. N stands for neutron. When you add the numbers, you get 238. Is that clear? Is that clear, everyone?
Sir.
Yes. Any problem? Okay. Now, what happens is, as I mentioned here just now, decay process happens. So decay process will emit any of this radiation. Okay, the first example is alpha particle. Okay, this one, alpha particle. So let us look at the decay of alpha particle. So alpha particle, actually, this is alpha particle. This one. Okay, that one is alpha particle. So as I mentioned earlier, that this uranium-238 is not stable. It is not stable. So what happens is it will release alpha particle. Okay, this alpha particle, which consists of two proton and two neutron, actually comes from uranium here. For example, let us take this one. This one and this one. So we have two proton and two neutron, for example. So actually, in this thorium, okay, thorium here, actually it misses it misses two proton and two neutron because it has been released, because alpha particle has been released. That's why you can see here, this is 92 proton and this is 90 proton. You can see there are two proton missing for thorium. Where where are the two proton? Now the proton comes. The proton is already here in the alpha particle. Okay, I hope that's clear for you. And you can see here also this is 146 neutron and this one is 144 neutron. You can see the difference. There are two neutron missing, right? There are two neutron missing. So the two neutron is actually here, the two neutron. Okay. And alpha particle is actually the helium nucleus, because you know that helium is one element. Okay, and then we are considering the nucleus of helium. That is what we call alpha particle. Is that clear for you? This is one example of alpha radiation. Okay, we are talking about alpha radiation. Okay, now we go on to the next one, beta radiation. Now we want to talk about beta radiation. You can look at the next example over here. Okay, now this is thorium. Okay, thorium. The number here is 234. Do you know where the number 234 comes from? Do you have an idea? 234 comes from where? Anybody knows?
The proton
Comes
and the
from?
neutron.
Yes, the summation of the number of proton and neutron. 90 plus 144, you get 234. Right. Okay. Actually, 234 shows the total number of proton and neutron. Now, okay, now look at the difference. Now, after the decay, the thorium here will change to protactinium, and then it will release beta particle. Okay, it will release beta particle. Beta particle is actually electron. Please remember that. Beta particle is actually electron. Okay, now look here. Do you see any electron here? Do you see any electron here?
No.
No. So where the electron comes from? Okay, actually, neutron, electron comes from neutron. It comes from neutron that transforms into proton. Okay, now let's take one proton here. Neutron. Take this one for example. This neutron here will transform into proton. Okay, it will transform into proton. So you can see there's only 90 proton here, but now it has 91 proton. Okay, so the neutron has transformed into proton, but it will release electron. Understand or not?
Yeah, I understand.
Okay, I repeat one more time. The neutron transform into proton, and at the same time it releases electron, and this electron is actually beta particle. That's why we have one electron here, and now the number of proton has increased from 90 to 91, but you can see the number of neutron here is 144. Now the number has decreased into 143. You see that number of neutron has decreased.
Yes, sir.
Okay, now that's why now the element thorium here has changed to protactinium, and the total number of proton and neutron is 234. And then we have electron, uh, which is released, and it is known as beta particle. Okay, that is about beta particle. And the last one we want to see here is gamma ray. Yes, as I mentioned just now, gamma ray. Gamma ray is not particle, it is ray, a type of ray. Okay, now look here. We have cobalt. Cobalt 60. Okay, now I can read the note here. Cobalt 60 star. Actually, we have one mark here. Okay, what is cobalt 60? Nucleus of cobalt, which is less stable. As I mentioned just now, why decay process happens? It happens because the nucleus is not stable or less stable. Okay, now can you tell me where the 60s come from? 60 come from summation
Mm,
of
neutron and
proton
proton.
and neutron, which is 27 plus 33. Right.
Yes,
Okay.
sir.
Now, what happens is cobalt. This is cobalt, and this is also cobalt. You see that? Is there any difference in terms of the number? 60? There's no difference, right? There is no difference. And then you can see here the number of proton and neutron also doesn't change, right? So what happens actually? You can see here now in this case the cobalt becomes more stable, but at the same time we have gamma ray. Gamma ray will be released. Okay, and actually the gamma ray is produced, not released. We better say that it produces gamma ray in order to be more stable. Okay, but the number of proton and neutron doesn't change. As I mentioned just now, that gamma ray is not particle. That is why you can see the number of particle doesn't change. It is actually a type of ray. Okay, why gamma ray is produced? Because this cobalt is not stable. To become more stable, like this, you need to produce gamma ray. That's why now we have three types of ray we have learned just now. Any question about uh, the decay? Any question? Okay,
Sir,
radio. Yes. Any question?
no question, sir.
Huh?
No question.
Okay. No question. Okay. Now, radioactive decay is a random and spontaneous process where an unstable nucleus emits radioactive radiation until the nucleus becomes more stable. Initially, it is unstable, then it becomes more stable. Examples of radioactive elements that have unstable nuclei and decay spontaneously by emitting radioactive radiation are as follows. Okay, this is what something we always hear, right? Compared to others, uranium, right? We say when we talk about nuclear, usually we say we relate it with uranium, right? Clearly, there are other elements also which produces radioactive radiation, like carbon-14, radon, and thorium. Now, okay.